Guys and gals, this is our last part of Chapter 9. We're going to be looking at dilations. Dilations are very different from the other three transformations that we have covered, so we need to keep that in mind. So let's start off. What is a dilation? Well, first off, it is typically not a congruence transformation. More often than not, it isn't. What it is, however, all the time is a similarity transformation. So we're not going to be creating images that are congruent. Instead, we are going to be creating images that are similar. So same shape, but not the same size. All right. So we need a center point that everything is either going to be going towards or away from. If you're in an art class, this is known as the vanishing point. For example, if we've got buildings in the foreground that appear large, but then again, buildings in the background that appear smaller, again, that gives us that illusion of distance. So for art terms, vanishing point, but for us, it's going to be the center of the dilation. We also need what's called a scale factor. Our scale factor is going to tell us how large or how small our image is going to be. So for example, if ABD is the original pre-image and we've got A prime, B prime, and D prime here, that's our new image. Our scale factor in this case would be a 2. Notice the distance from C to A is only half as far as it is from C to A prime. In other words, we've doubled the distance. Or B and B prime. Notice B is 1 unit away, whereas B prime is 2 of those units away. So we end up with double the distance, and notice we end up with something that is double the size in terms of those side lengths. So for example, if AD is 5 units long, then AD prime is going to be 10 units long. So again, this doubling effect, we're talking about side lengths and distances, not necessarily area measurements. So keep that in mind. So how does this number, we're calling it R in this case, we could use any variable. The book tends to use R though for scale factors. Other books might use K or some other value, it doesn't matter. How do our scale factors affect what we're doing? Well, if the absolute value of our scale factor is greater than 1, then we end up with something larger than what we started with. If the absolute value of that scale factor is between 0 and 1, then we're going to get a reduction. In other words, instead of, let's say this was our original image, and this is our final, then we would need a scale factor in this case of 1/2. That would take it from green down to blue, having that distance overall. And then if our absolute value is equal to 1, then we do end up with a congruence transformation. We'd end up with the exact same image. Now, I notice you're probably wondering, why are you putting it in absolute value? Well, here's the deal. If our value is positive, then our image and our pre-image will be on the same side of the points. Notice here we're to that right-hand side. If we had a negative scale factor, then what we would do is have to send it through the image, through the center here, and get our image on the other side. So it ends up rotating it 180 degrees and then making it that new size over here. And I'll show you how to do that. It's not too big a deal. Speaking of which, today you'll also want a compass. There it is, our compass and our protractor. The compass is going to help us with those distances again, so we're not constantly having to measure, say, using a ruler. And then your protractor is more for the straight edge. We won't necessarily need those angle measurements, but we will want a straight edge to get these auxiliary lines drawn in. So let's do it paper pencil first, and then we'll talk about the coordinate plane and see how we're doing. So let's start off with something like this. We'll do the same scale factor that we just saw. We'll use a scale factor of 2. So the first thing you'll do is take your straight edge. We're going to start with point C, go through point K here. And what we're going to do is we're going to draw that line basically as far as we can. So I want to extend that line all the way out. And again, don't draw these too dark. I'm going to draw them dark enough so that you can see them on the video. But again, don't do these too dark because that's not our ultimate goal. On a quiz or test, hint, hint, go ahead and leave those lines. Don't erase them. But again, don't draw them too dark because they're not our ultimate focus. Our focus is to get the new image. So again, we'll go from C through J. Yep, that's lined up good. Again, we want to draw it just about as far as we can. You don't want to have to extend these after the fact. And then through L, here we go. That looks good. Excellent. So here's what we got to do. Since our scale factor is a 2, I need to double this distance. So with our compass, that's easy to do. What I'm going to do is get C on the metal end, K on my graphite or my pencil, like that. So I need to double this distance. All right, well, there's 1. Here is 2. Cool. So K is 1 unit out. K prime is now 2 of those units out. Cool. So it's where it needs to be. Let's try J. Again, we'll have to really open this one up because J is a lot further out. There we go. So there's J. Take that same distance and we'll mark it in. So again, if J is 1 unit of measure out, then J prime has to be 2 of those out. In other words, J is going to be the midpoint between J prime and C, or whatever our center is going to be. All right, let's get L finished up. So we'll need to shrink that back down here. Let's see here, get all the way down to L. There we go, about like that. Same distance. We'll put the point on L, make our mark, and ta-da, there is L prime. All right, now we get to play connect the dots. Now, if you've got a ruler handy, one way to check yourself is to measure the original, measure the new, and all of your measurements should be doubled. So for example, there we go, that looks good. So for example, if I grab, and I'm going to measure in millimeters here, or centimeters rather, just because it's a finer measurement here. That's about 1.5 centimeters long. So that means K to L should be pretty close to 3, and it is. It's just a touch over 3, and I was a touch over 1.5. So yeah, that looks good. Or if I measure J to L, let's see, that's about, oh goodness, that's about 2 centimeters exact. So we should get about 4 here. Yep, and we're right at 4. So good. That is a excellent doubling. So again, we're just looking at that distance, and we'll double it out. All right, well, let's try it the other way around. Instead of getting larger, let's see if we can shrink it down. So again, we'll grab our straight edge. This time our scale factor will be 1/2 or 0.5. So again, I'm going to take this, and we don't need a long line this time because our image is going to be somewhere in here. So we'll just take our straight edge and we'll line it up with K and C, and we'll draw it in. And again, don't draw it too dark. We don't want to make it so dark that it's overwhelming our image, but I'm going to try to draw it in so that you all can see it. Now, if I can make my protractor get in the right spot, there we go. So we'll draw these in. There we go. So now, having things. We can do this one of 2 ways. If you have a ruler, all right, one way to do this is to take the distance from K to C, whatever that is. So in this case, I'm measuring about 2.6, and then we just have that. So it would be 1.3. So there's 1, 1, 2, 3. So K prime would be about here. All right, and that works. Okay. Another way to do it is to take your protractor and find that perpendicular bisector and use the midpoint that way. Since this is so small, I think that's going to be kind of a problem. Up here, we could do it. You know, if we were going from large to small this way, then finding those perpendicular bisectors would be a lot easier. Since this is so small and we're not technically doing full-blown constructions, I'm going to measure it just to make it easier on myself. But again, if you want to do those perpendicular bisectors, you can. In this case, I'm not going to. Again, those distances are really, really small, and I'm probably going to mess something up. So here we go. From J to C is about, if I can get this to line up, there we go, is at about, let's see, there's 4.1, 2, 3, 4, about 4.4. So 2.2 is about here. That looks good. So again, we're drawing, not constructing, and we're okay with that. So there's J prime. And then we need L. So let's try it. L, oh goodness, let's see. That is about 2.6 as well. Thereabouts. Yeah, about 2.6. So we need 1 point, let's say that's 1.5, 1.4, 1.3, about there. Cool. And there is L prime. All right, then we can play connect the dots. That's a little bit large. Here we go. And we're good to go. Now, I know some of you are thinking, oh, good Lord, if you're going to make us do this on a quiz or a test, how in the world is that going to work? You know, what if I'm off by a little bit? So long as you're close, you're good. I can guarantee you that this new image and this original pre-image are not exactly in a 1-to-2 relationship. They're close, but not quite. So again, this is not exactly half is not the end of the world. So long as you're close, that's what counts. Now, again, if I were to kind of do a rough sketch here, if this is what it was supposed to look like and you draw something like this as your final image, well, then yeah, you're wrong. So long as you got something that's close, you'll be okay. All right, let's try one more. This time we're going to see what happens when our scale factor goes negative. All right, so what do we do then? Here's how it works. The negative is going to affect everything and cause a 180-degree rotation. Because imagine if this were on an XY grid and we make everything opposite, that would rotate it 180 degrees, or a mirror image through that point C. So what I'm going to do is I'm going to try and make this distance just as large as I can, these new lines that I'm drawing in. So from K through C out the other side, I want to make that as long as I possibly can. I'm going to need all the distance I can get. So J to C, I'm actually going to make a mark out here in case I need to extend it, just so I can see it there. There we go, all the way through, and I might make this one just a touch longer. There we go, try and line it up there. There we go. Again, I'm going to need all the space I can get. And then this, we'll try and line it up as best we can. So with negative scale factors, negative in this case implying direction, what I'm going to do is measure from C to K. So we'll get that measurement done first. Looks like it's already there. I'm going to come to this side. So this is 1. This is 2. So notice that would make a new image the same size. This would make a new image twice the size, and that's what I want. So here we are at K prime. All right, let's do it for J. Actually, let's see about L, because we said L and K were about the same distance out. Yep, so we'll just keep that same distance there. And we'll go 1, 2. Again, the first one would be the same, so that would be a scale factor of 1. And then this one would allow for that scale factor of 2. And that's what we're looking for. In this case, negative 2, L prime. And let's see if we got enough room for J. Hopefully we've got enough done out there that everything will work out. So there's the distance to J. All right, let's come around to the other side. So here is 1 unit out. So notice these 3 points should give us a triangle the exact same size and shape as here, just turn the other way. We'll go 1 more out. Oh goodness, we just about didn't make it. There we go. And then that should get us out to J prime. All right, so let's play connect the dots. And notice what a negative scale factor does is not only scales up or scales down, so in this case, it's scaling up since it's an absolute value of 2, but the negative causes it to rotate, or we could say is a mirror image through the point of rotation. And again, so long as you're close. I know this one probably isn't exactly twice the size as that one, but it's close enough. And that's what I'm going for, folks. So long as you're close, you'll be good. All right, well, let's real quick try one on the coordinate grid. Those are a lot easier. We don't need near as many tools to get that done. So let's see what we've got here. Dilations on the coordinate grid. If P, point P with X and Y as those X and Y variables there, is the pre-image of our dilation with a center at the origin. So our origin is going to be that center of dilation. So everything's either going to shrink towards or expand away from that with some scale factor R, whatever it is. Then the final image for P prime is R, that scale factor, times X, and R, that scale factor, times Y. So in other words, if I want to take this image and dilate it by a scale factor of 1/2 or 0.5, then all I got to do is take all these numbers and multiply them by half. It's that simple. All right, so let's get the original drawn. So we go over 3 up 4. So there's F prime. G is 3, 6 over, and 10 up. So there is G. And then H is 1, 2, 3. Did I count that right? 3 over. Oh, I need to move that F. That's going to be in the way. We'll move it down here. F. There we go. So it's 3 over and 5 up. So it's a very narrow triangle. All right. So let's draw it in. Very narrow triangle. There we go. So there it is. Just a sliver of a triangle there. And to get my new points, it's really quite simple. To get F prime, G prime, and H prime, all I've got to do is multiply those original pre-image coordinates by 1/2, and I'm home free. So for example, F will be at 1.5, 2. If you want to write it as a decimal, you can. G would be at 3, 5. H would be at 1.5, 2.5. And when we graph those, folks, just so long as you're close, you don't have to be exactly in that right spot, just close. All right, don't hurt yourself trying to get it exactly at half. So let's graph F prime, and I'm going to graph it in a different color just to make it a little bit easier to see here. So I'm going to grab a red pencil. So we'll go over 1.5 and up 2. So right there, there's F prime. All right, G is 3 over and 1, 2, 3, 4, 5 up. So G is now in the original position that F was. I'm going to try and draw that in. There we go. So right in there. And then H is 1.5 over and then 1, 2.5 up. So goodness, it's like right there. So there is H prime. Draw it off to the side there. Let's play connect the dots here real quick. So that teeny, teeny, tiny sliver of a triangle just got even smaller. And there it is. So notice our triangle is shrinking towards the origin. Again, the origin, if you're in an art class, we'd call it the vanishing point as we're receding, say, into the background. But for math purposes, we'll refer to it as the center. Again, I strongly recommend that you bring a compass and protractor or other straight edge with you to class. So that way, as we're doing these, you've got some tools to use, especially when we're doing work like this. For the coordinate grid, not too big a deal. Again, a straight edge is what you'll need in a pencil in case you make any mistakes. If you have any questions or concerns, guys and gals, please bring those with you to class so that way we can answer them together. I look forward to seeing you. Have a good day.